we shall start derivatives of inverse trigonometric functions. So before going to inverse trigonometric function, if I have a function f of x whose domain is df, and if I do differentiation, I get f dash of x. So f dash of x exists in particular domain. It may be equal to its domain or may not be equal to its domain. So for what values of x f dash of x exists, we call it as domain of differentiability. Now in all the cases we cannot expect both domain of the given function and domain of differentiability equal, same. So few cases are differ where domain of the given function is not same as domain of differentiability. Take a function like a modulus of x. So I have a function f of x as modulus of x. It's defined for all real numbers. Now if I find its derivative, I get f dash of x as x by modulus of x, which is not defined for x is equal to 0. So what is the domain of f dash of x? So all x belongs to r minus 0. Now you see, compare these two. Domain of the given function is r, domain of its derivative is r minus 0. Now the function, if you take only the function, its derivative does not exist. But if I take the function except 0, its derivative exists. So we just check the conditions. If it is not differentiable in entire region, entire real numbers, we go back and we delete where it does not exist, and we take where it exists. In the same way, the function is differentiable in r minus 0. So modulus of x is differentiable in r minus 0. In the same way, if I enter to the inverse trigonometric functions, so just take sin inverse x. So I have sin inverse x as a function. So take it as y. Sin inverse x is a function y, and its domain x belongs to minus 1 to 1. Its range y belongs to minus pi by 2 to pi by 2. Y belongs to minus pi by 2 to pi by 2. Right? So minus pi by 2 to pi by 2 represents first quadrant and fourth quadrant. Remember. Now if I want to find its derivative, I get x is equal to sin y, and if I do derivative of x with respect to y, I get dx by dy is equal to derivative of sin y with respect to y, which is equal to cos y. So dx by dy, I got cos y. Now I want to get cos y in terms of sin y. So what relation we have? Dx by dy is equal to, I can write plus or minus root of 1 minus sin square y. Root of 1 minus sin square y. You see, sin y already I have as x. I replace dx by dy is equal to plus or minus root of 1 minus x square. Here I have to go for condition. What condition I have to check? So I am finding cos y and relating in terms of sine. So cos y relating in terms of sine. What is the range of the given function? The given function lies in minus pi by 2 to pi by 2. So fourth quadrant and first quadrant. In fourth quadrant and first quadrant, the value of cos is positive. So in place of plus or minus, I can stick to only plus. So plus or minus will be written as only plus. Now what is dx by dy? Dx by dy equal to root of 1 minus x square. Now I don't want dx by dy, I want dy by dx. In previous class we have learned what is that dy by dx can be written as 1 by dx by dy. With the help of this property, I find dy by dx, which is equal to 1 by dx by dy, nothing but 1 by root of 1 minus x square. Now you see where this differentiation exists. The differentiation of this particular function exists if it is not equal to 0 and it exists. So its domain is from minus 1 to 1. Its domain is minus 1 to 1. We don't need to check for all real numbers. If we want to check for all real numbers, we have to take 1 minus x square greater than or equal to 0. But we are not checking for all real numbers, we are checking in between minus 1 and 1. From minus 1 and 1. If I take minus 1, I'll get 0. If I take plus 1, I'll get 0. If I take what values in between minus 1 and 1, then definitely x square value is less than 1. So the value, this value will be positive. So what we have to eliminate from its domain? So we cannot take 1 minus x square greater than 0, that we need to remember. Now we have to delete minus 1 and plus 1 from its domain. Now what is the domain of f dash of x? Nothing but y dash dy by dx. F dash of x nothing but dy by dx is equal to 1 by root of 1 minus x square for all x belongs to minus 1 comma 1 open. I have eliminated minus 1 and plus 1. See, the domain of the given function is minus 1 to 1. The domain of its differentiability is minus 1 comma 1. See, the domain will changes. The function is differentiable. Sin inverse of x is differentiable in minus 1 to 1 open. It's not differentiable in minus 1 to plus 1 closed. Sin inverse x is differentiable function if I consider its domain from minus 1 to 1 open. If I consider domain closed minus 1 to 1, it does not exist, so we can say it is not differentiable. So what is the differentiation of cos inverse x? Derivative of cos inverse x. So in the same procedure we can do, we get d by dx of cos inverse x, which is nothing but equal to minus 1 by root of 1 minus x square. In the same way, d by dx of tan inverse x we get as 1 by 1 plus x square. D by dx of secant inverse x and d by dx of cosecant inverse x and d by dx of cot inverse x. This all we can find with the help of this rule. See, I write all the formulas. Secant inverse x is my 1 by mod x into root of x square minus 1 for x greater than 0. So this and all we learn while doing derivatives. The differentiation of given things, the derivation. Now you see, cosecant inverse x minus 1 by modulus of x into root of x square minus 1, where modulus of x is greater than 0. Here also we should take modulus of x greater than 0. Next, cot inverse x minus 1 by 1 plus x square. Now you see we have a relation between tan inverse x and cot inverse x, which is nothing but minus of its tan inverse, and cos inverse x and sin inverse x, which is nothing but negative of sin inverse x. I am talking about its derivative. Derivative of cos inverse x is negative of derivative of sin inverse x. In the same way, secant inverse x and cosecant inverse x. So one of them will prove. So let me take cosecant inverse x. So if I have a cosecant inverse x, so we are going to find its derivative. So I am taking y as cosecant inverse x. So what is the domain of x? Modulus of x is greater than or equal to 0. Modulus of x is greater than or equal to 0. Sorry, is greater than or equal to 1. And range, what is the range of cosecant inverse x? Y belongs to cosecant minus pi by 2 to pi by 2 minus 0. Minus pi by 2 to pi by 2 minus 0. So it's defined for all values which are lying in modulus of x greater than or equal to 1. Right. I have y is equal to cosecant inverse x. I can write y is equal to sin inverse of 1 by x. What we have learned in inverse trigonometric functions. The relation between cosecant inverse and sin inverse. So we can write cosecant inverse x as sin inverse of 1 by x. Next, if I do derivation, so if I do differentiation with respect to x, so I get dy by dx is equal to So differentiation of sin inverse x, just now we found 1 by root of 1 minus x square, but it is not x. Whenever it is not x, what we have to do? We have to take it its derivative d by dx of 1 by x. Now 1 by root of, if I take LCM, I get x square minus 1 by x square into, it acts as x power minus 1, x power n formula, n into x power n minus 1, which we will get as minus 1 into x power minus 1 minus 1, x power minus 2. So I get here minus 1 into x power minus 2. So simplify this, root of x square by root of x square minus 1 into minus 1 by x square. Now root of x square can be written as modulus of x. What we get? What is the outcome of x square? Root of x square plus or minus x. So plus or minus x can be written as modulus of x by root of x square minus 1. And next, here what we have? Minus 1 by into minus 1 by x square. So what I have? X square. X square can be written as modulus of x whole square. So modulus of x and square will be gets cancelled. So d by dx of cosecant inverse x is equal to, so what is remaining? Minus 1 by modulus of x into root over x square minus 1. The differentiation of given function exists for x not equal to 0, it exists. So we cannot take x 0, and x square minus 1 should not be 0, it should be positive. It should not be 0 and it should be positive. So what I can take? X square minus 1 should be greater than 0, we should not take equal to. So I get x square greater than 1. Then if I take square root, what I get? Modulus of x is greater than 1. See here its domain is modulus of x greater than or equal to 1, and we got it domain of differentiability as modulus of x greater than 1. So it is not differentiable at minus 1 and 1. The same thing we can repeat. The domain of differentiability is modulus of x greater than 1. The function is differentiable in mod x greater than 1. It is not differentiable in its own domain. Right? Next. So if I go to the next topic, which is nothing but substitution. Differentiation by using substitution. So substitution method. Before going to substitution method, we have to recall the formulas what we learned in trigonometry. So we learned sin 2x, cos 2x, sin x in submultiple angles, cos x in submultiple angles. We have to recall all those. With the help of that only we can do this particular substitution method. Right? I have a cos 2x formulas. Cos 2x is equal to cos square x minus sin square x, and 1 minus 2 sin square x, and 2 cos square x minus 1. We use these two formulas more frequently. So I want to relate the given function cos 2x in terms of only sin x, otherwise sin x in terms of cos 2x. So how I relate? I get 2 sin square x as 1 minus cos 2x. In the same way, 2 cos square x as 1 plus cos 2x. If suppose I want to get its submultiple angles, if I have here x, we get here x by 2. If I have here x, we get here x by 2. So if you have a denominator form, 1 minus cos 2x by 1 plus cos 2x, 2 will get cancelled, square and square gets cancelled, sin x by cos x, which is nothing but tan x. If you have a inverted, nothing but 1 plus cos 2x by 1 minus cos 2x, 1 plus cos 2x by 1 minus cos 2x, how we can write? We can write it as 2 cos square x by 2 sin square x, we get in terms of cot x. So if you don't have in terms of 2x, if you have in terms of x, we get submultiple angles, nothing but tan x by 2 or cot x by 2. Now, how I am going to relate this 1 minus sin x or 1 minus sin 2x, 1 plus sin 2x or 1 plus sin x. See, this we cannot relate directly in terms of cos 2x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. See, this we cannot relate directly in terms of cos 2x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. So for that particular purpose, what we have to do? We have to relate this 1 minus sin x or 1 minus sin 2x or 1 plus sin x. So for that particular purpose, particular thing, I am converting this sin x and cos 2x in terms of sin x and sin 2x in terms of cos. So how I can convert the sin in terms of cos? Sin of theta can be written as cos 90 minus theta. Sin theta can be written as cos 90 minus theta. So I use that. Then I get 1 minus cos 90 pi by 2 minus x. Same way I can rewrite this one as 1 minus cos pi by 2 minus 2x. Now it is in the form of 1 minus cos x. It is in the form of 1 minus cos x. 1 minus cos x can be written as 2 sin square x by 2. Sin square x by 2 nothing but pi by 2 minus x whole by 2. So we get 2 sin square pi by 4 minus x by 2. So in this way, these conversions we have to use based on the given problem, right? Now one more other conversions what we have with the help of identities. So in particular quotients, if you see like a square minus x square or a square plus x square. If you see a square minus x square or a square plus x square, what we have to do? A square minus x square. So we have a relation. I can write sin square x as 1 minus cos square x. So if I able to write this one in that particular form, I can simplify this one in that form. Further, what I can do, I can substitute x as a sin theta or a cos theta. Just I substitute whether a sin theta or a cos theta. If I substitute, what I get? A square minus a square sin square theta. So I convert this one. I take a square common. 1 minus sin square theta. So 1 minus sin square theta is nothing but equal to cos square theta. I get a square cos square theta. So in place of theta, you can write here y, alpha. The variables is invariant. Right. Now I have a square plus x square. Just recall identities. 1 plus tan square theta, 1 plus cot square theta. Right. So in place of x, what I am going to substitute in this case? In this case, I am going to substitute either tan theta or a cot theta. Because I have here a, I am using a tan theta or a cot theta. If suppose I have like b square minus x square or b square plus x square, then what we use? We definitely use x as b sin theta or b cos theta. Here x as b tan theta or b cot theta. Right? It depends on the particular constant what we have here. Right? Okay. Suppose I have here 4 minus x square. Then 4 minus x square. Then what we do? Just we write it as 2 square minus x square. So I write it this x as 2 cos theta or 2 sin theta. Okay? Sure? Right. I go to this one. So I substitute x is equal to a tan theta. Then what I expect? A square plus a square tan square theta. I took a square common. 1 plus tan square theta, which is nothing but secant square theta. Now one more thing. If I have x square minus a square, then see if I have x square minus a square, again one more possibility is that, which is nothing but x is, you substitute x as a cosecant theta or a secant theta. A cosecant theta or a secant theta. How? Why? How and why? See, if I use cosecant theta with the help of cosecant identity, cot square theta can be related as cosecant square theta minus 1. So then if I substitute that, a square cosecant square theta minus a square. So I can take a square common. So I took a square common. I get cosecant square theta minus 1. So cosecant square theta minus 1 is cot square theta. After that, I can do the differentiation. At last, replace theta by, replace this particular x by a cosecant theta. Otherwise, replace this theta. If I want to say replace the theta, so how can I replace that particular theta? X by a, because my answer we should write our answer in terms of x only. So cosecant theta is a into cosecant theta is equal to x. So cosecant theta equal to x by a, and theta is equal to cosecant inverse x by a. Theta is equal to cosecant inverse x by a. This substitution we have to do at last. Okay, right. Still, if I have one more, what is that? If I have like sin theta plus cos theta, sin theta plus cos theta, it can have some a sin theta, b cos theta, like that. So in this particular things, what we have to do? We have to express this. Already we did while finding range and domain of these type of particular things in trigonometry. Just recall what we did. We just replaced this a as some r cos theta, b as some r sin theta. A as r cos theta, b as r sin theta. Substitute. Take all common. Cos a sin b plus sin a cos b. So already here we have theta. In place of this we use alpha. Already I have theta now, so we should not use the same variable. So we have to use other variable than this. So I have used theta, I use here alpha. If you have functions like root over a minus x by a plus x or its reciprocal, then so what we have to do? We should substitute x as a cos theta. Reason? Previous case we have discussed. If you are able to convert this one as 1 minus cos theta by 1 plus cos theta, 1 minus cos theta can be replaced as 2 sin square theta by 2. Right? Shall I do? I do it. Root of a minus a cos theta by a plus a cos theta. Root of, I take a common, 1 minus cos theta by again a common, 1 plus cos theta. A gets cancelled. 1 minus cos theta is 2 sin square theta by 2 by 2 cos square theta by 2. 2 gets cancelled again. The root of sin square theta by 2 by cos square theta by 2 can be replaced as tan square theta by 2. Root of tan square theta by 2 is tan theta by 2. So to get in these particular things, we use these substitutions. Now we shall do the problems. Write down problem number 1. Discuss the domain of differentiability of the following functions. Domain of differentiability of functions: sin inverse x, cos inverse x, cosecant inverse x, tan inverse x. Right. So what are the domains? All the functions you take. Sin inverse x, just now we found the derivative of sin inverse x. So its domain is minus 1 to 1, but it does not exist at minus 1 and plus 1. Therefore what we got? 1 to minus 1 to 1 open. In the same way, cos inverse x minus 1 to 1 open. Cosecant and secant inverse, modulus of x just greater than 0. Tan inverse x, so what do we get? Tan inverse x, its derivative is 1 by 1 plus x square. 1 plus x square is always greater than 0. It never equals to 0. So its domain is all real numbers. Right. Now, next one. I have a function like tan inverse of x root x. Tan inverse of x root x. Feel like this particular thing has some x. Don't get confused. Okay, use this one as u. Tan inverse of u. What is the derivative of tan inverse of u with respect to u? With respect to u. Shall we do in that way? Right. Let it be by. So I am finding dy by dx. If I want to find dy by dx, what formula I have to use? Tan inverse of u. Right? U is a function which is defined as x root x. U is the function which is defined as x root x, and y is a function which is defined as tan u. So if I want to find a dy by dx, what I should do? dy by du into du by dx. What is dy by du? Differentiation of tan u. Sorry, it's tan inverse u. Differentiation of tan inverse u with respect to u. Nothing but 1 by 1 plus u square into du by dx. Differentiation of x root x with respect to x. So let me do it. X root x can be written as x power 3 by 2. So how x power 3 by 2? X into x power 1 by 2. 1 plus 1 by 2, 3 by 2. Right now, it's a differentiation n into x power n minus 1, 3 by 2 minus 1. Right? Now, the simplest way, the answer, simplified answer, 1 plus x root x whole square into 3 by 2 into x power 1 by 2. X power 1 by 2 is nothing but root x. So what we get? 3 root x by 2 into 1 plus x square into x. X square into x, nothing but x. Okay, next problem. Secant inverse of cosecant x. Secant inverse of cosecant x. Right? So this function, now we are going to do differentiation. Take it as y dy by dx. This time I am going with the formula and substitution. I feel this one as particular x. Then what is the derivative of secant inverse x? 1 by modulus of x. Modulus of x is nothing but modulus of cosecant x into root of x square minus 1. The right formula, secant inverse x whole dash is equal to 1 by mod x into root of x square minus 1. Now what we got? Mod cosecant x into root of cosecant square x minus 1. So this I felt as x, but it is not x. I have to do differentiation of the particular thing, dy by dx of cosecant x. So now what we get? 1 by mod cosecant x root of cosecant square x minus 1, which is nothing but cot square x. Which is nothing but cot square x into d by dx of cosecant x minus cosecant x into cot x. Minus cosecant x into cot x. 1 by mod cosecant x into root of cot square x, we get modulus of cot x into minus cosecant x cot x. Minus cosecant x into cot x. Now you see, plus or minus a into plus or minus b. If I take plus, I should take here also plus. So plus into plus, plus. Minus, minus. Okay, I cannot take here plus and here minus. Like that 4 cases will not arrive. We get only 2 cases. If it is plus, this also plus. If it is minus, this one also minus. Right? Now plus into plus, plus, minus into minus, plus. We get it as 1 by cosecant x into cot x into minus cosecant x into cot x. Both will get cancelled. I get dy by dx as minus 1. We go to the next problem. F of x is equal to cot inverse of tan x. Same way you can do this problem. The next one. Sin inverse of x plus secant inverse of 1 by x. Sin inverse of x, y is equal to sin inverse of x plus secant inverse of 1 by x. Find y dash. Find y dash. Right? They have given y and we can simplify the y. Y is equal to sin inverse of x plus secant inverse of 1 by x. Feel it as secant inverse of x. How I can write secant inverse in terms of cos? Secant inverse x can be written as cos inverse 1 by x. So with the help of this formula, I can write this one as cos inverse 1 by 1 by x, which is nothing but x, and we know sin inverse x plus cos inverse x, which is equal to pi by 2. So I get y is equal to pi by 2, which is a constant. So y dash is equal to 0. dy by dx is equal to 0. Next, take a problem like cos inverse 1 minus x by 1 plus x. The given function cos inverse of 1 minus x by 1 plus x, which is equal to y. We consider which is equal to y to find its derivative. So differentiate with respect to x, then I get dy by dx equal to derivative of cos inverse x minus 1 by root over 1 minus x square. In place of x I have 1 minus x by 1 plus x the square. So as it is not x, I have to perform its differentiation. The denominator is 1 plus x, which is in the form u by v square 1 plus x the whole square, right? Now v u dash 1 plus x into derivative of 1 minus x is minus 1 minus u v dash 1 minus x into derivative of 1 plus x is 1, right? Now simplifying this, minus 1 by square root of 1 plus x the whole square minus 1 minus x the whole square divided by 1 plus x the whole square, right? So which is equal, into this one, 1 plus x into minus 1 minus x, minus 1 into 1, minus into 1 minus 1, minus into minus x plus x by 1 plus x the whole square. Now minus, so we get root of 1 plus x whole square, square root gets cancelled, it comes into numerator, which is 1 plus x by root of 1 plus x the whole square, which is nothing but 1 plus x square plus 2x minus 1 minus x the whole square. So we can find this particular thing away and I can substitute it. So I do that. Or we can use directly the formula. What is that? A plus b whole square minus a minus b whole square, which is equal to 4ab. Right? Okay. That's what we simplify. 1 plus x square plus 2x minus of 1 plus x square minus 2x. Right? We get 1 plus x square plus 2x minus 1 minus x square plus 2x. So I got 4x. So I get here root of 4x into minus x and plus x gets cancelled. So I get minus 2 by 1 plus x square, right? Square and this gets cancelled. So now I get minus into minus 2 by 2 root x into 1 plus x. Now again 2 and 2 gets cancelled. So I get dy by dx as dy by dx, which is equal to 1 by root x into 1 plus 8 minutes I can do take x into sin inverse of x whole square plus 2 into root of 1 minus x square into sin inverse x minus 2x, which is given as y. We consider it as y. We have to find dy by dx. So dy by dx equal to, consider this, it is in the form of uv dash. So x into sin inverse x whole square. You consider this one as x. So x square. What is the derivative of x square? 2x, which is nothing but 2 into sin inverse x. So whenever it is not x, we have to do derivative of that particular thing. So what we do? D by dx of sin inverse of x. Right? U v dash got over. Next v means I get sin inverse x whole square into u dash, derivative of x is 1, plus 2 is a constant. How to leave 2 like that? Next, 1 minus x square, if I fill as u, I get 1 minus x square under root into sin inverse x derivative is 1 by 1 minus x square under root plus sin inverse x into 1 minus root of 1 minus x square derivative. Root of 1 minus x square derivative, if I fill it as x, root x derivative is 1 by 2 root x, 1 minus x square, but it is not x, so I have to differentiate again. So d by dx of 1 minus x square plus, sorry, it's minus 2 into differentiation of x with respect to x is 1. Now simplify that. dy by dx is equal to x into 2 sin inverse x, d by dx of sin inverse x root of 1 minus x square plus sin inverse x whole square into 1 plus 2 in bracket gets cancelled, so I got here 1 plus sin inverse x into 1 by 2 root 1 minus x square can be written as 1 by sin inverse x by 2 into root of 1 minus x square. d by dx of 1 minus x square, 1 is 0 and minus x square is minus 2x, close, minus 2, and this 2 and 2 gets cancelled. So what's the final answer? dy by dx is equal to 2x into sin inverse x by root 1 minus x square plus sin inverse x whole square plus 2 plus 2x wait plus 2 into minus x minus 2x into sin inverse x by root of 1 minus x square minus 2 plus 2 minus 2 gets cancelled. 2x into sin inverse x by 1 minus x square under root and minus 2x into sin inverse x by root 1 minus x square gets cancelled. So we get dy by dx as sin inverse x whole square. Next, tan inverse of sin x by 1 plus cos x. Next one, tan inverse sin x by 1 plus cos x. Don't go directly to tan inverse x derivative, just you have a chance of simplifying this one. If you are able to convert this particular thing in terms of tan, it will be very easy for us to simplify. So for that purpose, in the beginning what I explained, just to go through that, sin x is sin x, can go with the submultiple angles like y is equal to tan inverse of sin x submultiple angles 2 sin x by 2 into cos x by 2 by 1 plus cos x. If you have a plus, it's 2 cos square. If you have a minus, we get 2 sin square, right? 1 plus cos x can be written as 2 cos square x by 2. 2 and 2 gets cancelled, square and cos gets cancelled. We get y is equal to tan inverse of sin by cos, tan x by 2. So tan inverse of tan theta is theta, tan inverse of tan x is x. So what we get, y is equal to, in place of x I have x by 2, I get x by 2. Now you do dy by dx is equal to 1 by 2 into differentiation of x with respect to x is 1. So my answer is 1 by 2. It one more. Cot inverse of cosecant x plus cot x. Question number 10. Cot inverse of cosecant x plus cot x. Take this function as y. Again same solution. Just try to convert this particular thing in terms of cot. Then you simplify. So I write y is equal to cot inverse. So cosecant x plus cot x can be written as cosecant x 1 by sin x, cot x cos x by sin x. Denominator we have sin x, so I get cot inverse of 1 plus cos x by sin x. Just what we did in the previous problem, the same thing. There we have sin x by 1 plus cos x, where we have 1 plus cos x by sin x. So I use the same result. So I get cot inverse of cot x by 2. You have to follow the previous problem for this. So y. So y is equal to x by 2. dy by dx is equal to 1 by 2. So go to one more problem, which is y is equal to sin inverse of x by root 1 minus x square. Given question number 11. Y is equal to sin inverse x by 1 minus x square. Root of 1 minus x square. Prove that 1 minus x square into dy by dx minus xy equal to 1. Right? So to prove this, so you can find dy by dx and you substitute, you simplify. Otherwise, by transferring this to left side, you can continue differentiating both sides. Right? So I will do that. Y into root of 1 minus x square is equal to sin inverse of x. Now take differentiating with respect to x. So what the short form reverse? Differentiation with respect to x. Then it is uv formula, u v dash d by dx of 1 minus x square under root plus v u dash dy by dx equal to d by dx of sin inverse x 1 by root 1 minus x square. Okay, and now we get y into, it is in the form root x, 1 by 2 root x, so 1 by 2 root 1 minus x square, and it is not an x, so I have to do its derivative. So derivative of 1 minus x square is minus 3x plus root of 1 minus x square into dy by dx, which is equal to 1 by root 1 minus x square. So if I take 1 minus root of 2 into root of 1 minus x square LCM, then what happens? See, y into, sorry, you can cancel 2 and 2, no? So I cancel 2 and 2, then I can take only 1 minus x square as LCM. So root of 1 minus x square as LCM. So I get y, which has minus y into x minus yx plus 1 minus x square into dy by dx, because root 1 minus x square into root 1 minus x square, 1 minus x square, which is equal to 1 by root of 1 minus x square, which will get cancelled. Now what we got? 1 minus x square into dy by dx minus yx can be written as xy, minus 1 equal to 0, otherwise equal to hence 2. Okay, so take one more problem. Tan inverse of 2x by 1 minus x square. So we entered the substitution method. Tan inverse of 2x by 1 minus x square. 12 minus first one. Tan inverse of 2x by 1 minus x square. Sorry. Consider it as y. Let x is equal to tan theta. So I am taking x equal to tan theta only. So if I substitute here, 2 tan theta by 1 minus tan square theta, which is nothing but tan 2 theta. So I have that form. So I use that. Right? So if I substitute that, I get y is equal to tan inverse of 2 tan theta by 1 minus tan square theta. 2 tan theta by 1 minus tan square theta. So I get y is equal to tan inverse of tan 2 theta. Tan 2 theta. So y is equal to 2 theta. So what is theta from this? Theta is equal to tan inverse of x. So I get y is equal to 2 into tan inverse of x. The same thing, we have a formula what we learned in inverse trigonometry. Tan inverse of 2x by 1 minus x square, which can be rewritten as 2 tan inverse of x. Use formula and we can write this one. We can avoid these many steps. Okay. Now I want to find its derivative. dy by dx is equal to 2 into tan inverse x. So tan inverse x derivative is 1 by 1 plus x square. Therefore my answer, dy by dx is equal to 2 by 1 plus x square. 2 by 1 plus x square. Next, one more. Sin inverse of 2x into root of 1 minus x square. Given fourth one, 12th and 4th only. Sin inverse of 2 x into root of 1 minus x square. Let's consider it as y. I consider this one as y. Then I have to go with the substitution method. See, if I take this one as sin theta or cos theta, why I am going to take it as sin theta or cos theta? Just recall substitution. I have here root of a square minus x square. A square minus x square. So what we have to do? We have to substitute x as a sin theta or a cos theta. In place of a, we have only one, right? 1 into sin theta is nothing but sin theta. Let x is equal to sin theta. If I substitute sin theta, what we get? Sin inverse of 2 into sin theta and root of 1 minus sin square theta, which is equal to y. So sin inverse of 2 into sin theta, root of 1 minus sin square theta is cos theta, 2 sin theta cos theta, which is equal to y. So further, y is equal to sin inverse of 2 sin theta cos theta, sin of 2 theta. Sin of 2 theta. Now, dy by dx. I want to find dy by dx. Before that, sin inverse of sin 2 theta can be written as 2 theta. Then y is equal to 2 into theta is sin inverse of x. Now, dy by dx is equal to 2 into differentiation of sin inverse x, 1 by 1 minus x square and then